these absolute value equations, but today we're going to be dealing with this b value in your equation. This first part is just another review. What does the absolute value function look like? A v. What's the domain for all absolute value functions? All real numbers. Or negative infinity to infinity. And then for the parent function, for the range, how far down do I go? 0, and then you go up to what? Infinity. Okay, and then for set builder for the range, it's going to be y is greater than or equal to 0. So just a review of the parent.
Wait, what'd you ask? Oh my god.
Me?
Yeah.
Wait, what?
I didn't ask anything. I said this is the review of the parent function. So, how low did your range go?
No, you said something before that.
I don't remember.
I mean, between those two, you said something, and it sounded like a question. We're gonna go back on that record right now.
Okay. So we are going to have values in this B. Now, the first thing you need to know, anything on the inside your absolute value bars, anything on the inside, it is opposite and it's horizontal.
So these are the same thing from yesterday?
Kind of. All right, so it's horizontal. So pretend, once again, that you have your ball of silly putty or Play-Doh or what have you. Okay? Probably silly putty because we're stretching and pressing. So you have your ball of silly putty, right? If you are going to vertically compress it, is it getting skinnier or fatter? Skinnier. So horizontally, I think, did I say that right? Let me start over. You have your silly putty.
Yep.
Horizontally squishing it. You're getting skinnier, right? Okay. So horizontally compressing is the same thing as vertically stretching.
Oh.
Okay. I was about to
Yeah.
get confused there.
So that's why the B is so confusing, because horizontally compressing is the same thing as vertically stretching. All right, and so then vice versa. Say you have your ball. Okay. If you are going to horizontally stretch it, it's getting fatter, and it's the same thing as vertically compressing. All
I
right.
need to write that down.
That's beautiful.
Yes. So that is why the B is so confusing, all right? Because it's kind of like the opposite of the vertical stretching and compressing.
So horizontally, press.
All right. Once again here, the B values, I forgot to put the absolute value bars in there, so stick in those absolute value bars.
On all of them?
No, just the first two. Just the first two. So if your B value is bigger than 1, all right, so like 2 or 3 or -8. Remember the negative sign we're not worrying about.
You're so inconsiderate. What if
I said negative infinity. I'm gonna cry.
All right, if your B value is bigger than 1, all right, and remember you're not worrying about the negative, you are going to horizontally compress, which makes your graph get skinny.
Wait, you said,
Skinny legend.
So the number's bigger than 1, your graph is getting skinnier. You're either horizontally compressing it or you're vertically stretching it. It's going to do the same thing to the graph, and that's when the numbers are bigger than 1. If your numbers are decimals or fractions, like 1/2 or 0.7 or 2/3, all right, any numbers between 0 and 1, you are going to horizontally stretch. And so your graph is going to get fatter. So when you have decimals and fractions, your graph gets fatter. When you have whole numbers bigger than 1, your graph gets, it doesn't have to be a whole number, but when you have numbers bigger than 1, your graph gets skinny.
Wait,
Will we have mixed numbers?
is that a
Maybe.
-7?
Oh no.
That's a-
No, 0.7. Sorry,
Oh, okay.
0.7.
You say fat. You should say thick.
Just give me legend.
All right, so the confusing part. Your graph isn't changing, all right? Like I said, a horizontal compression, a vertical stretch, the same thing is happening on your graph. What's different is the way you're describing your translation, all right? So because the numbers are inside, that's why we're describing them as horizontal stretches or compression. If the number was on the outside, you would describe it as a vertical stretch or compression. But your graph, the same thing is happening. Does that make sense?
A vertical stretch is the same as a horizontal compression.
Yes.
And vice versa.
Yep. All right, and then the last part, if your b is less than 0. So if your b is less than 0, that's a negative, right?
What did you say?
Is that a reflection too?
It is going to be a reflection, but you are going to reflect across the y-axis.
Oh no! Now you done really switched the game. I can't.
All right, so now let's think about this for a second. Let's think about the reflecting across the y-axis.
I am confused.
All right.
Paper time.
Patty paper time. Yes, I know.
Patty paper.
Everything you learned yesterday is just flipped.
Yeah. I don't like being in the upside down.
All right. So yesterday we reflected over the x-axis, right? And so when you reflect over the x-axis, it was upside down,
Oh no.
right? No, change your graph. Today we're reflecting over the y-axis. If you flip it over the y-axis, does it change?
Oh no.
No. Okay, now let's think about why it doesn't change. What do the absolute value signs do?
Make it positive.
Make it positive. So if I have a negative sign in here, what do the absolute value signs do?
Make it positive.
Make it positive, so it doesn't change your graph. So if you have a negative sign inside your absolute values, it does not change your graph.
What if it's on the outside?
Then it flips over the x. So outside flips over the, that's what we did yesterday. So remember, if it's on the outside, it flips over your x. If it's on the inside, it flips over your y.
I need to really know.
So do we still have to put reflection?
Yeah, technically it is still a reflection over the y-axis. It just doesn't change your graph.
Does not. Will not. Can.
I have a question.
Yes.
Make me lunch.
Because it's part of your function. Yeah. All right. These three graphs right here. So I want to regraph them, and I want to state the transformations. Now remember, when you're graphing it, your graph isn't changing, right? As opposed to how we graphed them yesterday. So on this one, we're still going to treat the 2 like slope, where we start here at 0, 0, and we're going to go up 2 over 1, up 2 over 1, and graph it just like you normally would. Right? Because your graph isn't changing. Angie, is that a phone?
Yeah, I'm sorry.
And if you look at your graph, horizontally compressing, vertically stretching, it doesn't matter. That's what your graph is doing.
Yes.
Because the 2 is on the inside of my absolute value bars, I am going to describe my transformation as a horizontal compression.
Oh, okay.
Because the 2 is on the inside. The graph looks the same, but because the 2 is on the inside, I'm going to describe it as a horizontal compression.
Would it be wrong if you said it was a vertical stretch?
Yes, because the 2 is on the inside.
Okay. Yeah.
So wait, when the numbers are on the outside, then
Vertical.
Oh my god. And it's so sick.
Huh?
yeah.
We'll do the same thing.
Mm-hmm. Your graph would look the same, but you describe it differently.
Of a name.
Yeah. I know. All right, so what you need to, the big thing here, outside stuff is vertically changing. Outside is vertical. Inside is horizontal. Outside is vertical. Inside is horizontal. Good question.
So if they just gave you the graph and the line, you wouldn't be able to tell the formulas because you don't know if it's going to be like.
You would be able-
on the outside or the inside.
You'd be able to tell, but you would have like 2 different options. Does that make sense?
And it'd still be the same if you don't like one.
Yeah. So if I like just gave you that graph and you either gave me this one or with the 2 on the outside, they both would be right. Yeah. All right. Now there's one other part here. you're going to be given words to describe these transformations. And when you have stretches and compressions, you're going to see these words that say by a factor of. That's just telling you how much you're compressing and stretching.
So it would be 2.
Almost. Now, what you need to remember, inside is changing, right?
-2.
No. So this 2 is not being added or subtracted, right?
Yeah.
It's being multiplied. So how would you do the opposite of multiplying?
Divide.
Divide. And so
1/2.
1 over 2. So to describe the factor, you do the reciprocal.
To describe
Why?
Because you want to do the opposite, right? But the opposite of something being multiplied is dividing, which is the reciprocal. Yeah, because 2 times x. The reason why you do, you change the sign for the c, because it's minus or plus, yeah. Make sense? So, for the b value, reciprocal.
Reciprocal.
All right, so let's do this one. So, on the second one, is that going to be a horizontal compression or a horizontal stretch?
A horizontal stretch.
Horizontal stretch by a factor of what?
2 over 1.
2.
Good. By a factor of 2 or 2 over 1?
Is it gonna be the same thing?
What? Oh, okay.
All right. When you graph it, though, what number do you use for slope?
The 1/2.
1/2, right? Because remember, the graph doesn't change. It's just how you're describing that's different. So you're going to go up 1 over 2 still. And so your graph should be horizontally stretching, which it is. It's horizontally getting fatter.
Me.
Oh my god.
Current mood ATM.
Vertically divide.
You get taller? Duh.
Yep.
That's not fat.
That is fat. Have you ever noticed
Vertically
that?
compressing.
Vertically get fat. It doesn't help.
If you squish down. Like, I don't know, if you squish down, you would get fatter.
If I was short.
Me trying to be short.
All right.
If I was short.
Okay. Very good. So this next one reflects over the y-axis. And the negative sign. This is the only thing that you're not going to treat as slope, is the negative sign on the inside, because the negative sign does not change your graph. So if this is negative, you just ignore it. It reflects over the y, it doesn't do anything.
But if it was outside.
So we just redraw?
Yeah.
Okay.
So if it was outside, you would, but if it's inside, you just ignore it, and you have the same graph. Nope, it's just reflect. What's up?
That's a fat bet.
All right. Almost done. Flip it over on the back.
Do we have a practice for this?
It's on the back of the one from yesterday.
Oh, so I might as well just do my word.
All right, I want to do the word part first. I want to do the word part first, and then we're going to do the graphs. All right. Writing absolute value equations from transformations. So now I'm going backwards. I'm giving you the transformations. I want you to write it in words. All right, I know that these are going to be the holding spots. The A, the B, the C, and the D. And you just need to figure out where your numbers are going to go.
Do we need to memorize that?
Yeah.
Oh,
But I mean, not really, because it's up there.
Are you gonna leave it up there forever? Never?
when we take the exam.
I probably will take it down for the test.
I just saw this. Thank you. You got it.
You're welcome.
You also, you didn't even notice that I erased this on your paper.
You erased
All right.
Look.
So the B is like invisible?
I wrote on
The B?
Yeah, it's invisible. Because in here, it's not there.
Dumb thing.
I'll talk about that in a second.
Significant.
Oh, did I forget to put it? Oh, I did. Dang it. No, I just forgot to put it up here.
Forgot what?
The B. No, we are still doing it.
That's fine.
Why would you do that?
Because that's what teachers do.
Sorry.
We gotta keep it moving.
I forgot. All right, come back down here. All right.
Yes, that's it.
Like I said, we're going to take these words and we're going to put them where they're supposed to go right here. So I'm going to start down here with the down 4. All right, down 4. Where would that translation go? The A, the B, the C, or the D?
D.
I'm sorry, what letter?
D.
D, good. D. So, is it going to be a -4 or a +4? Minus, because you're going down.
What the woo? Hold on. You're going too keep going down.
Mhm.
So when you be a positive 5 inside there?
Very good. So left 5. Left is horizontal. It's going on the inside, and you have to do it, think, opposite. So,
Is it the C?
uh-huh.
X plus 5.
X plus 5. That's the C.
And then B.
All right. Now, stretch vertically by a factor of 3.
So it's 3 on the outside.
Good. So it's outside because it's vertically. And do I keep it as a 3 or do I flip it?
It's a -3, right?
Oh,
You keep it as.
you keep it as a 3.
What? But it's a -3.
Yeah, I'm almost there. I'm almost there. Hold on. You keep it as a 3 because the outside stuff stays normal. If it was on the inside, you do the reciprocal. All right, and then the last part, reflect across the X. If you reflect across the X, is your graph changing?
Yeah.
Yes. So where is your negative sign going to go?
Part of the 3.
In front of the 3.
Finally, the one thing I knew.
So there's no B.
Yes.
And there's no B.
It's what?
See,
I'm a
I would
scholar,
have to like
a young
stay
one
and
at
look
that.
at that other paper where we first did it.
All right, next one.
My shoulder hurts. Oh my god, look how it's doing.
All right. Stretch vertically by a factor of 5/4. Where is that going to go?
Inside.
Vertically.
Outside.
Outside because it's vertical.
Will it be 4 over 5 or still 5 over 4?
Still 5/4.
I thought you squat.
Only inside. Inside stuff is the only thing that changes. So inside is horizontal, inside changes. Outside is vertical, outside stays the same.
It goes up to you.
That's plus 2 at the very end, right?
Very good. +2 at the very end. And you just have a regular X on the inside.
What the woo? I've never
Oh
seen
my god,
that
I'm smart.
Okay, on this last one, I need to change it because I didn't put a horizontal example on here, which was stupid of me. So make this a stretch and make this horizontally. What? So I forgot to put a horizontal example, so that's the only reason why I'm changing
Why are
that.
we stretching? I mean, why are we scratching it out to put
Scratching it out.
Why are we scratching it out to put stretch?
Because I'm switching it so it's a horizontal example, so you have one of those on your notes. 'Cause I forgot to put one on there.
This is
So it's
another
going
lot
to be
of
5
things
over
is-
2 in the inside,
Yes,
right?
ma'am.
All right, good. So stretching horizontally by 5/2, is it going on the inside or the outside?
The inside.
Inside. And what do you have to do to the 2/5?
It's 5 over 2.
vertically.
5/2.
Plus, oh, no.
Okay. Reflect across the x-axis. Is that going to change your graph?
No.
Yes.
Yes,
Mhm.
it is. Yes.
So is the negative going on the outside or the inside?
Outside.
Very good. And then the last, translate right 1 unit.
Oh, right.
That's
That's
-1.
all in the inside.
-1 on the inside. Now, you have to put these parentheses here because 5/2 is your B. This is your C.
Why didn't you put a parentheses over there first?
How do we know that 5/2 is a B?
Because you
Because I said by a factor of.
Oh.
Wait, what happened to the X? That was
She
with
told
the
me.
1
It's just right here.
So you don't have to have 2?
No, we only just have one X.
So there's no D.
There's no D. Or, yeah. Alright, so you have to have the parentheses. This is the reason why. Jump up here to your word problems. Do you see how this is multiplied out 3x plus 6?
Yeah.
That is no good. You cannot graph this from here. -6, -2 is not your vertex. Okay? That is not a vertex. You have to take your B out to get your vertex. Because your B is multiplying by the x minus
So you
c.
have to divide it.
Yeah. So whatever number's in front of the x, that's going to give you your B value. So in here, my B value is 3. So when you take the 3 out of 3x, you're just left with x.
X plus 6.
Uh-huh.
3, you mean?
No, plus
2.
2.
6 divided by 3 is 2.
I can real math, y'all.
And then you still have the -2 here. The reason why you have to do that is because now I can get my vertex. Where is my vertex at?
-2,
-2, -2.
Yes, King.
All right, now what is my slope? Or the number kind of like slope?
No.
Exactly.
Just ask.
What is the number kind of like slope?
3.
3, very good. So you're going to go up 3 over 1. at 3 over 1.
Oh no way.
Sorry, man. I was finding the axis symmetry.
Big schmood.
No, I missed
You know what? I made a quadratic function.
So axis of symmetry is x equals -2. Domain are all the real numbers, or negative infinity to infinity. Range, you go down to -2, up to infinity. Yes, I am still recording.
It's been 20 minutes.
20 minutes. We're almost done. We just have one more.
If you really go this far into the video,
I don't know.
you can look at your statistics.
Follow me on Instagram at l_y.e.
Oh my gosh.
Okay.
Oh my God.
Okay.
Number 2.
Make sure you add that to the description.
Like and subscribe to this channel if you like.
DM for business inquiries.
No.
All right, so for number 2, what number is my b value that I'm going to pull out?
Negative x.
Close.
Negative 1.
-1, yeah.
So funny.
-1. So you're going to take a -1 out.
Turn to a positive 3.
And very good, and that turns to a positive 3.
Oh no, I did something wrong.
Look, you see that meme again?
So where's my vertex at? -3, 1.
I still don't see why.
All right, now, do I use the -1 as a slope? No, because it's on the inside. So be really careful. This -1, it's not affecting your problem.
Wait, it's inside.
You don't get why it's not affecting?
One, right? Because there's nothing there.
Would it just be 1 over 1?
Okay.
Why did I change this?
No, why?
You're taking out whatever's in front of x. So there's a -1 in front of x. So that's what I took out.
Okay,
You want
so
X,
why
Y,
did
Z.
you?
Why do you change it?
-3 divided by -1 is a positive 3.
Because you're distributing it later.
Okay, so why did you take out the 3 on number 1, but then you could use that as slope, but you couldn't use the -1 as a slope?
Because the -1, the absolute value bars, turn it positive.
Oh,
So it's not affecting. Because right now, this -1 means you're reflecting over the y, which doesn't change your graph.
Okay.
But this means you're horizontally going to compress it, which does change your graph.
It made it seem like we weren't going to use it at all. It's like,
Just when you're graphing, you're not going down, you're just...
Wait, so the 3 on number 1, why didn't it change to a -3 if it's inside the bar?
This? It's not a -3.
No, why didn't it change?
Because it's not negative right here. So just whatever this is, you take out.
But
So
isn't it inside so it change?
it's already inside. So once it's inside, you just, leave it alone. If you were to describe this... Yeah. If you describe this translation, you would say this is a horizontal compression
oh no.
The reason why
by 1/3. That's where you would flip the...
The reason why the vertex is -3, I'm asking, is it because we're multiplying it by the -1?
No, it's because whatever this is, you switch the sign.
So always switching it.
Yep. If it's on the inside, yep. Axis of symmetry is -3. Domain, negative infinity to infinity.
Know when to do this form versus the other form. Like if something's in front of X, but like the other on the back, we still did it there. Something
Not on the inside, though.
on here.
Because you're gonna have